Imagine waking up one day to find that your compass is pointing south instead of north. Sounds like science fiction, right? But this phenomenon, known as a geomagnetic reversal, is a very real part of Earth's history. The question is, could these reversals trigger catastrophic disasters? Today, we're diving into the science behind geomagnetic reversals, exploring what they are, why they happen, and whether they could spell trouble for life on Earth. Let's start with the basics. Earth's magnetic field is like an invisible shield, generated deep within the planet by the movement of molten iron and nickel in its outer core. This magnetic field protects us from harmful solar radiation and guides everything from migrating birds to our GPS systems. But here's the kicker. Earth's magnetic field isn't static. Over millions of years it has flipped multiple times, with the magnetic north and south poles swapping places. These events are called geomagnetic reversals, and they've happened hundreds of times in Earth's 4.5 billion-year history. So, how do we know this? Scientists have found evidence in ancient rocks. When lava cools and solidifies, tiny magnetic minerals align with Earth's magnetic field, locking in a record of its direction. By studying these rocks, researchers have mapped out a timeline of reversals. The last major reversal, called the Brunhes-Matuyama reversal, happened about 780,000 years ago. On average, reversals occur every 200,000 to 300,000 years, but the timing is irregular. Some periods, known as supercrons, have lasted tens of millions of years without a flip. Now, you might be wondering, what causes these reversals? The answer lies deep in Earth's core. The churning of molten metal in the outer core creates a dynamo effect, generating the magnetic field. But this process isn't perfectly stable. Changes in the flow of molten material, influenced by heat from the inner core and Earth's rotation, can weaken or destabilize the field. Over thousands of years, the magnetic field can weaken, fragment into multiple poles, and eventually flip. It's a slow process, not an overnight switch, typically taking 1,000 to 10,000 years to complete. Here's where things get interesting. Could a geomagnetic reversal cause disasters? Let's explore the possibilities. One major concern is the weakening of the magnetic field during a reversal. The field can drop to just 10% of its normal strength, leaving Earth more exposed to solar wind and cosmic rays. These high-energy particles could damage satellites, disrupt power grids, and even increase radiation levels on the surface. In 2003, a powerful solar storm caused blackouts in Sweden and damaged transformers in South Africa. During a reversal, with a weaker magnetic shield, such events could become more frequent and severe. But what about life on Earth? Would humans and animals be in danger? Some scientists speculate that increased radiation could pose health risks, potentially raising cancer rates in exposed populations. However, the atmosphere still provides significant protection, absorbing much of the incoming radiation. Studies of past reversals show no clear link to mass extinctions. For example, the Brunhes-Matuyama reversal didn't coincide with any major die-offs. Fossils from that time suggest life carried on as usual, with no evidence of catastrophic disruption. That said, some species might face challenges. Many animals like pigeons, sea turtles, and whales rely on Earth's magnetic field for navigation. During a reversal, the field's chaotic behavior could disorient these creatures, potentially affecting migration patterns. But evolution is resilient. Species have survived hundreds of reversals, adapting to temporary disruptions. It's unlikely a reversal would wipe out entire ecosystems. Another concern is the impact on technology. Our modern world depends heavily on satellites for communication, navigation, and weather forecasting. A weakened magnetic field could make satellites more vulnerable to solar storms, leading to costly failures. In 1989, a solar storm caused a 9-hour blackout in Quebec, Canada, affecting millions. During a reversal, similar events could become more common, potentially disrupting global economies. Could a reversal trigger natural disasters like earthquakes or volcanic eruptions? Some have speculated that changes in the magnetic field might influence Earth's crust, but there's little evidence to support this. The forces driving plate tectonics and volcanic activity originate deep within the planet, far removed from the magnetic field's influence. Studies of past reversals show no consistent correlation with increased seismic or volcanic activity. So while the idea of a reversal triggering a supervolcano or megaquake makes for great headlines, it's not backed by science. Are we due for a reversal? The last one was 780,000 years ago, which is longer than the average interval between flips. Some scientists argue we're overdue, while others point out that reversals are unpredictable. Earth's magnetic field has been weakening over the past century, particularly in an area called the South Atlantic Anomaly, where the field is already 30% weaker than elsewhere. But a weakening field doesn't guarantee a reversal. It could stabilize or take thousands of years to flip. If a reversal does happen, it won't be apocalyptic. The process is gradual, giving us time to adapt. Scientists are already developing technologies to shield satellites and power grids from solar storms. International space agencies monitor solar activity closely, and early warning systems could mitigate disruptions. For humans, the biggest inconvenience might be recalibrating our compasses and updating navigation systems. So, should we worry about geomagnetic reversals? The science suggests they're a natural part of Earth's cycle, not a doomsday trigger. While they could pose challenges for technology and navigation, catastrophic disasters like mass extinctions or global earthquakes are unlikely. Life has thrived through countless reversals, and humans, with our ingenuity, are well equipped to handle the next one. Thanks for joining me on this deep dive into geomagnetic reversals. If you found this fascinating, let me know in the comments, and don't forget to subscribe for more science explorations. Until next time, keep looking up, whether your compass points north or south.